Hello, CC3 students, and welcome back. In this video, we're going to be reviewing how to create equivalent fractions using big ones. So there's two times when you would, or two different scenarios where you would need to create equivalent fractions: when you are simplifying a fraction or writing it in simplest form, or when you're trying to create an equivalent expression or equivalent fraction with a different denominator. In both cases, you're going to use what's called a big one. A big one means you have the same numerator and denominator. So something like 2 over 2 or 5 over 5 or 6, 6 or 7, 7, something like that. So an example where you would be using big ones to create an equivalent fraction in simplest form would be something like 10/18. This is a fraction that is not simplified, and the way that we know it's not simplified is because 10 and 18 have a factor in common. So you think about what are the different ways to factor 10, to write 10 as a product, and what comes to mind is 2 times 5 or 1 times 10. Really, those are the only ways. And for 18, you can do 1 times 18, 2 times 8, 2 times 9, and 3 times 6. So of all the different ways to factor both, which ones end up with common factors or the same number in the numerator and denominator? And if you think about it, we can factor out 2 in both of these. So in other words, I'm rewriting 10 as 2 times 5 and 18 as 2 times 9. Now what this does is it creates what's called a big one, because 2 divided by 2 is actually equivalent to 1, and 1 is therefore kind of eliminated or canceled out, as a word that people oftentimes use, and you're essentially left with the fraction 5/9, which is equivalent to 10/18. These represent the same amount of area or the same place on a number line. The only difference is 5/9 is what we consider simplest form. Now, in a different way, if we weren't asked to do simplest form, we can also create equivalent fractions if we're trying to make a different fraction or this equivalent fraction with a different denominator. So let's take, for example, 2/3. And let's say I want to change 2/3 into, I don't know, 18ths, right? So I want to create an equivalent fraction of 2/3 to 18. So in other words, 2/3, 1/3 jumps is equivalent to how many 1/18th jumps? So to do this, we also use big ones, but instead of factoring out, we're going to multiply this by a big one. So in other words, it just becomes a multiplication problem. What times 3 gives you 18? Well, 3 goes into 18 6 times. So in order to keep this fraction equivalent, we're going to multiply it by the big one, 6, 6. Because again, you're really just multiplying it by 1, which doesn't change the amount that you have. So 3 times 6 is 18, 2 times 6 is 12, and these are equivalent fractions. This was in simplest form, but we now changed it to 12/18. Why would you ever need to do that? Well, if you had to do something like 2/3 minus 5/18, you would need a common denominator to be able to subtract these, which is why you need to know how to understand how to change that into 12/18. So if we were to multiply this by 6, 6, that big one, our expression becomes 12/18 minus 5/18, which is 7/18. So the key here is that we use big ones to create equivalent fractions that represent the same amount or same area, but are written using different numerators and denominators. So now we're going to look at some worksheet practice examples where we're simplifying fractions, and then some IXL examples of identifying equivalent fractions on a number line. Okay, so first up, we're going to be simplifying each fraction. And again, to simplify means to find a common factor in both the numerator and denominator, which would then create a big one. So in the numerator, I have 5, and in the denominator, I have 20. So if I think about it, the only way to write 5 as a product is 5 times 1. For 20, I can do 20 times 1 and 5 times 4, and that's pretty much it. Oh, excuse me, and 10 times 2. So we're trying to factor both of these so that you end up with the big one, same number in the numerator and denominator. So what I notice is that 5 looks like it is a common factor here. So if I'm going to simplify this fraction, I'm going to factor out the big one of 5. So that means in the numerator, I'm going to write 5 as 5 times 1. And in the denominator, I'm writing 20 as 5 times 4. That creates the big 1 of 5/5, which I can then just simplify as 1. And that leaves us with the simplified fraction of 1/4. All right, over here, number 3, same thing. We have 40/35. This is an improper fraction, but we're just going to leave it improper because simplifying doesn't necessarily mean we have to make it a mixed number. So if I think about the factors of 40, I think of 4 times 10, 2 times 20, 5 times 8. Is there anything else? Not that I can think of. Oh, and 1 times 40. 35 is 7 times 5, and I'm pretty sure that's about it. That goes into 35. 1 times 35, yeah. So this again, we're going to be factoring out that common factor of 5. Now you don't need all of this here, so feel free to get rid of that, or you can even do that step really just in your head. We're going to factor out 5. So 40 is 5 times 8, and 35 is 5 times 7. What big 1 did we just create? We just created the big 1 of 5/5, which once we factor out that big 1, that leaves us with 8/7. And again, you can just leave it as an improper fraction because nowhere in the directions does it ask you to write it as a mixed number. All right, let's take a look at number 5 here, 36 and 30. So if I was to try to do this in my head, I might start off by thinking like, what goes into 36 and 30? You know what? The first thing that pops into my head is that they're both even. So I might say 2. So I might start off this process of going like, okay, 36 is 2 times 18, and 30 is 2 times 15. So what I'm essentially doing is I've created a big 1 of 2 over 2, or 2 halves, and that leaves me with 18/15. But there's something strange about 18/15. 18 is 3 times 6, and 15 is 3 times 5. So that just means that I didn't factor out what's called the greatest common factor as a big 1. I still have some ways to go. So these are actually equivalent fractions. 36/30ths and 18/15ths are equivalent, but I'm trying to simplify each fraction, meaning I would need to continue on. So now I'm thinking to myself, okay, so second step here, I got to keep going. What's the common factor of 18 and 15? 3. So I'm going to write 18 as 3 times 6, and 15 as 3 times 5. That creates the big 1 of 3/3, and I'm left with 6/5. Now, do 6 and 5 have any common factors? Well, 6 is only 2 times 3, and 5 is 1 times 5, so no, I know I am done here. So just because this required 2 steps doesn't mean that I couldn't do it. So in other words, I could have done it in 1 step if I had just factored out 6, but I just chose to factor out the 2 and then the 3. We're going to go over a few more examples here, maybe a couple more tougher ones, like let's just kind of finish out the odds. All right. Over here, 32 and 28. 32 and 28, let's see, what goes into both of those? 32 is 4 times 8, and 28 is 4 times 7. So let's try that. 4 times 8 over 4 times 7 creates a big 1 of 4/4. And that leaves me with 8/7. Are there any common factors of 8 and 7? Nope. So I know I'm done here. 18 and 24. Well, I know 2 goes into 18 and 24, so let's start with that. 18 is 2 times 9. 24 is 2 times 12, so that created a big 1 of 2 halves. And then that leaves us with 9/12. 9/12 doesn't seem like it's fully simplified. 9 is 3 times 3, and 12 is 3 times 4. So I can keep going here, so I'm not quite done. So 9 is 3 times 3, and 12 is 3 times 4. That creates a big 1 of 3/3. And is it my final answer? We get 3/4. Yes, that's my final answer, because 3 is just 3 times 1, and 4 is 2 times 2. All right, last one here. Now notice that 11 and 12 do contain bigger numbers, so I definitely suggest working just step by step, taking it one step at a time and seeing how far you can get. So I know 18 and 108 are both even numbers, so I'm going to just factor out 2 to start. 18 is 2 times 9, and let's see, 2 goes into 10 5 times, and goes into 8 4 times, so that's 2 times 54. All right, that gives me a big 1 of 2 halves. Take out that big 1, and that leaves us with 9 54ths. Ooh, 9 54ths. Let's see, does 9 go into 54? I think it does. 9 goes into 54 6 times. So we are not done here. So we're going to factor out 9. 9 is 9 times 1. 54 is 9 times 6. Do I believe that? Yeah, 9 times 6. And 9 ninths is our second big one. And our final answer here is 1/6. And anytime 1 is in your final fraction, you've got to be done. All right, so that wraps up the worksheet practice examples of looking at simplifying. Now let's look at some examples where we are using equivalent fractions to create new denominators. Okay, so in this case, we're going to be using number lines to create equivalent fractions. So there's a couple ways to do this. You can either use big ones, or you can just use the number line to figure it out. So this number line is broken up into fourths. We have 1/4, 2/4, 3/4, and 4/4. And we need to graph 1/2 on a number line. So algebraically, we're trying to change 1/2 into a number of fourths. So if I wanted to do this kind of like the long way or the algebra way, I would multiply this by a big 1 to create a number of fourths. So 2 times what is 4? 2 times 2 is 4. So I'm multiplying 1/2 by the big 1, 2 halves. So 1 times 2 is 2. So I know 1/2 is equivalent to 2/4. Now the other way to do this is actually just to use the number line. So I know from 0 to 1, if I was to graph 1/2, I would be making 2 equal sized jumps to get from 0 to 1. So if I jumped like this and then there, are those equal sized jumps? I don't think so. Or if I jumped like from here to there, are those equal sized jumps? No. So the only way to make 2 equal sized jumps is to jump to 2/4 and then 1/2, which means since it took 2 equal sized jumps to get from 0 to 1, this is where we would put 1/2 on the number line. In either way, it both shows you the same idea, that the correct answer here is 2/4. All right, let's try another one. Now in this case, we're going from 1/3 to a number of ninths. So again, there's 2 ways to do this. I can either go algebraically, how do I change thirds into ninths? So I'm going to use a big 1 here. 3 times what is 9? 3 times 3 is 9. So the big 1 that I'm using is 3/3. 1 times 3 is 3. So I know that 1/3 is equivalent to 3/9. Or I can use the number line. I'm going from 0 to 1, and I have to make 3 equal sized jumps there. So this one's a little bit tough, but if I use like 2, 1, 2, 3, nope, that didn't work, okay. And clearly using like 1 isn't going to work, okay. Let's see if I can use 3. If I go 3/9, and then 3/9 again, and then 3/9 again, look at that. In 3 jumps, it took to get from 0 to 1, each jump has 3/9 in it, which means this is 1/3, 6/9 is equivalent to 2/3, and then your 3/3 or your 1. Either way, both of these tell us the same thing, that our answer here is 3/9. All right, another similar one. This one is asking me to change fourths into eighths. So again, if I wanted to convert and write an equivalent fraction of fourths into eighths, what big 1 would I use? 4 times what is 8? 4 times 2 is 8. So I multiply by the big 1 of 2 halves, and that gives me 2/8, because 1 times 2 is 2/8. Or use the number line. From 0 to 1, I have to make 4 equal sized jumps, Well, I can't make 1/8 jumps because that would take 8 of them. So let's try taking 2/8 each time. There's 2/8, 2/8, 2/8, 2/8. Notice that each one required 2/8, and that's 1, 2, 3, 4. That means that 2/8 is equivalent to 1/4. 4/8 is equivalent to 2/4, which, by the way, is also equivalent to 1/2. And 6/8 is equivalent to 3/4. So every 1/4 jump requires 2/8, which, hey, that's where this big 1 comes from. This stands for how many 8s are in a fourth. Either way, the correct answer here is 2/8, and we can move on to our submission. Okay, now this is a tougher example here because it's asking us to graph 1/2 on the number line, but we no longer have all of the dash marks. All we know is that this is 8/6, which leads us to understand that each one of these is jumping by a number of 6. 4, 6, 5, 6, 7, 6, right? You get the idea. Oh, wait. 2, 3, 4, 5, 6, 7, 8. Oh, I wrote 7 instead of 6. 6, 6. Oh my gosh, I messed up that whole thing. Oh, well, you get the idea. So these are, it's asking us to find a number of 6. So in other words, how do I go from 1/2 to a number of 6? What big one do I use? Well, let's see. 2 times what is 6? 2 times 3 is 6. So I'm multiplying by the big one 3/3. 1 times 3 is just 3. Or I can still use the number line, but I want to make sure I identify 1. So 6, 6 is a big 1. So this is where 1 is on the number line. So from 0 to 1, I need to make 2 jumps. So if I go by 2 6 each time, I end up making 3 jumps, and that's not what I want to do. So what if I go by 3 6 each time? There we go. So that means there are 3 6 in every 1/2, and that's what this big 1 means. That's why we multiply by the big one of 3/3. Either way, there's our answer, and we hit submit. Okay, so that's the end of our video. Remember, there's 2 ways to create equivalent fractions. Simplest form means to factor out a big 1, and to create a different denominator means to multiply by a big 1. Hope that you enjoyed the video. Have fun creating equivalent fractions, and see you next time.